So what's the difference between speed and velocity? The quickest answer to that is that speed is just some amount. 60 miles per hour, for example, is a perfectly good example of a speed. For it to be a velocity, you also have to give me some direction. So 60 miles per hour north, for example, is a velocity. Technically speaking, velocity is what we call a vector quantity, where speed is just a scalar. I did a video on the difference between these two. Go take a look at it. But let's put a concrete example to this just to illustrate why this is important. So say you're on a lake, you're sailing, the current is carrying you 10 miles per hour west, and the wind is carrying you 10 miles per hour north. You'd be tempted to say, okay, 10 miles per hour plus 10 miles per hour, add that up, I'm moving 20 miles per hour total. That is not correct. The only time that's correct is if both the current and the wind would be carrying you in the same direction. In this example, they're not, right? To do this properly, we have to add these as vectors. We add the vector of the velocity due to the current to the vector of the velocity due to the wind. You can put this together in a right triangle. That's how we add vectors in this case, tip to tail. And the total velocity at this point is the connection between the two, which in this case is the hypotenuse of this right triangle. And you might remember from high school geometry that to find the hypotenuse, you can do the good old Pythagorean theorem. So in this case, the magnitude of your velocity, which is the total speed you're going, actually turns out to be about 14.1 miles per hour, not the straightforward addition of the two speeds. So hopefully that makes sense on why it's important to consider things in vectors when it comes to dealing with complex situations. And thanks for watching.